a lot of the continents were covered with ice. And evolutionists noticed this too, right? In fact, they believe that this happens cyclically. It happens over long periods of time, so there have actually been many ice ages, but they don't attribute it to a global flood. They attribute it to the tilt of the Earth. There's one big problem with this. If the entire Earth is cooling down because it's all tilting away, everything is cold, including the oceans. And the only way you're going to get the huge amount of precipitation, to get huge amounts of snow, and therefore huge sheets of ice, is if you have nice warm oceans at the same time that you have really cold continents. You can't have the entire system warming up and cooling down together. Well, welcome down here to Legacy Hall for Ice Age Giants. So my name is Stephen Lavelle. I am one of the zookeepers down at the Ark, so I get to work with all of our animals down there. Specifically, I work in programs, so I get to talk about our various ambassador animals. I basically get to talk about all the animals in the zoo. And we're going to be talking about some of them in this program today, and some of the animals they're related to. Specifically, I get to do lots of live animal programs where we bring our animals out on stage. So if you come visit us at the Ark, you can see our programs throughout the day. This is not a live animal program. This is a dead animal program. So who's excited about dead animals? All right. We are going to be learning about some of the biggest animals who ever lived here, right here in Kentucky, and more generally here in North America. And so to talk about those animals, I think it's actually good to start with the biggest animals who live here now. So who are the biggest animals on this continent, here in North America? Well, we got some pretty good-sized bears, right? Like grizzly bears. They can get 750 pounds. And polar bears, way up north, they are actually the largest land carnivore in the world. They can get over 1,000 pounds. But carnivores don't usually get as big as grazing animals. Right? Animals who eat grass and leaves, they can get a lot bigger, like the deer. So we have elk. They can reach over a ton in weight. And even bigger than that, we actually have the largest living deer anywhere in the world on this continent. Anyone know what that animal is? It is the moose, yes. Moose can reach over a ton as well, but they still don't come close to the largest land animal on this continent. That would be the American bison, yeah. The biggest of those get 3,800 pounds, nearly 2 tons. We got some big animals on this continent, right? And none of them are anywhere close to the largest ones that have lived here. We find much, much, much bigger animals as fossils. So we're going to be looking at some of the biofacts, bits and pieces that animals have left behind. And we're going to look particularly at ones that were discovered here in Kentucky. There's a place a few miles south of here called Big Bone Lick State Park. Anyone ever visited down there? Yeah, it's a fascinating place if you love paleontology, the study of these dead things buried in the ground, because this is a natural salt spring. It's a place near the Ohio River where salt comes up to the surface. Lots of grazing animals need salt in their diet, so lots of animals gathered there to lick up that salt, and a lot of them died there and were buried there. And ever since people have been exploring the Ohio River, going back to the 1600s, they have been discovering big bones at the salt lick. So that's why they called it the Big Bone Lick. And they discovered some huge animals, some of them discovered for the very first time there, like this right here. This is one of several hundreds of this type of bone that were found at Big Bone Lick. This is a molar tooth. Pretty good sized one, right? Yeah, the largest of these weigh up to 20 pounds. And hundreds of these were found at Big Bone Lick. This animal was first discovered there, and no one was entirely certain what this animal was, because it was a little bit strange. Even the early discoverers of this animal, looking at its bones, recognized that it looked like a pretty familiar animal. It looked like a living animal. It looked like an elephant, which is a little bit odd. We don't have any elephants living in Kentucky now, do we? So no one was really sure what this animal was. They called it the incognitum, or the unknown animal of Kentucky. So this animal came to the attention of Georges Cuvier, who was the leading French zoologist around 1800. And if anyone could figure out what was or wasn't an elephant, that would be this guy. He was the first person to identify Asian and African elephants as different species, because they have different sized ears, their backs are humped in a different way. So if anyone could figure out what this was, it would be him. So he compared the bones of living elephants to the incognitum. He also compared them to the bones of another elephant-like animal that had been discovered up in Siberia, in eastern Russia. It's a very cold place, certainly a place where we find no elephants, but there were hundreds of bones from an animal that the natives called mammut, though we usually translate it as mammoth. So, Cuvier compared all these bones, and what did he find? Well, looking at the teeth of the mammoth, they look an awful lot like the teeth of a modern elephant. They have these low ridges for grinding up grass and leaves and other fibrous plants. That's what elephants use, kind of like rhinestones, to eat those plant materials. So, the mammoths are very similar to the elephants. The incognitum, on the other hand, does it have low ridges on its teeth? It's got these huge bumps there. Cuvier called this animal a mastodon, and he concluded that it must not be an elephant. It must be a different species, so not related to elephants. But there was also something strange about the mammoths, too. Even though their teeth are like elephant teeth, their skin is not. Now, it'd be odd that we have their skin, because we usually just find bones from these animals, right? But a lot of the mammoths are mummified. Their skin is perfectly preserved. One of the earliest discovered ones, the Adams mammoth there, was covered with chunks of skin. And even more recently, we have found fully intact adults. And here is a little calf that was found in 2010. And here's one that was found this summer in Canada. And so when we find these mummified animals, what we notice about the mammoths is they are covered in dense brown fur. Here's a little bit of that real mammoth hair. Are elephants covered in dense brown fur? Nope, they're nearly hairless. So Cuvier concluded that this animal wasn't an elephant either. And these are not animals you could hide somewhere, right? They're way too big to be just hiding in some far corner of the world. No one sees any animals exactly like this today, so Cuvier concluded that these animals were extinct. In fact, these were the first animals to be declared extinct, completely gone from the surface of the earth. This is before the first dinosaurs had been discovered. And Cuvier discovered many other fossils of animals that were extinct, nowhere to be found. Huge animals. And so he concluded, or he posed this question, why has not anyone seen that fossils alone gave birth to a theory about the formation of the Earth? That without them, no one would ever have dreamed that there were successive epochs in the formation of the globe. He's proposing that these bones tell us that there is a great ancient past, long before human history, when these animals lived and died and were buried by cataclysmic events before anyone could have known or written about them. So is he right? Well, I do think that these bones will tell us about a history, but I think that history can only be understood in light of what we see in Scripture. So really, to do that, we need to back up and answer some of the big questions about these bones, or let's call them the mammoth questions. First off, are these animals related to living species? Are mammoths and mastodons related to elephants, or are they something completely different? And when do they actually live, right? That's a little bit hard to place. Most importantly, what happened to them? Why are they extinct now? Why don't we see these kinds of animals? So, to start off with, are they related to living elephants today? Well, what does it mean to be related? How are you related to your relatives, like your siblings? You have the same parents, right? And you're related to your cousins because you have the same grandparents. In fact, how is everyone in this room related to each other? Go far enough back and we have the same ancestors, right? We all go back to Noah and his wife. We go back to Adam and Eve. But even if we didn't know that, could we test in the present day and show that humans are related to each other? There's a pretty easy way. Can a man from one part of the world marry a woman from a completely different part of the world and reasonably expect to have children? Yes, because we are all from the human race, right? From one group that God made. So, can we do this with animals? Well, let's try it out. Let's start with cats. Anyone got a house cat for a pet? Yeah, cute little animals. Are they related to tigers? Can they breed with tigers? No. That's probably not going to work. No, I think the tiger's going to eat the house cat. But we can breed a tiger with a lion, and we get a hybrid that's called a tigon or a liger, depending on who the father was. We can also breed a lion with a leopard, and we can breed a leopard with a cougar, and we can breed a cougar with an ocelot, and you probably see where this is going. We can breed an ocelot with a house cat. We can also breed a house cat with the sand cat, which is the smallest wild cat today. So from the largest species of cat to the smallest, they are all connected together. They belong to a single group, even if you can't breed every single individual in there. Actually, you can also breed house cats with servals, who can also breed with caracals. Ocelots can breed with bobcats, who can breed with lynxes. And leopards, lions, and tigers, they can all breed with jaguars. And that's every genus of cat living today connected together. So the cats belong to one group. They are related to each other. How about the camels? So down at the Ark, you can meet our dromedary camels. That's Gomer up there. He's a retired rides camel. So he is 16 years old and a beautiful guy, so he loves showing up on photos. Anyway, he is the variety that comes from the Middle East and North Africa, the one-humped variety of camel, the dromedary. But there's also the Bactrian camel that comes from Central Asia. That's the two-humped variety. Well, these two animals can breed, and they'll make a hybrid called a tulu. It does not get 3 humps, sorry. Just gets one big hump there. Now, over on the other side of the world, in South America, there are llamas and alpacas. There's Japheth the llama from down at the Ark, and there's one of our alpacas that's actually here at the Creation Museum. They can breed and make a hybrid called a cuartzo. That's Rico, who used to live here at the Creation Museum. Now, why have I put all these up on the map together? Because you can artificially breed a dromedary and a llama, and you will get a hybrid called a kama. It is a real thing. You can go look it up. What does that tell us? These animals are all related. They are from the same group. And that's exactly what we would expect from Scripture, because we're told in the beginning, when God made the beasts of the earth, he made them according to their kinds, and the livestock according to their kinds, and everything that creeps on the ground according to its kind. That word, kind, appears a lot in the account of Genesis. When God made the animals, he made them in groups. He made those groups to multiply on the earth. So he designed these animals to reproduce more animals like themselves. Though, are we going to expect any members of the cat kind to breed with any members of the camel kind? No. They're from separate groups, separate ancestors God made, but within their groups, they can produce lots of variety of shape and size and color. So, let's go back to our elephants. Are modern elephants related to each other? Asian and African elephants? Well, let's consider Madi. He's the little guy there on the screen. So he was born at the Chester Zoo in England in 1970. Now, if you look at his mother, you'll see that she's an Asian elephant. She's got the small ears, she's got the high sloped back, but if you look at Madi, you'll see he has the much larger ears of an African elephant, because his father was an African elephant. He's the only known hybrid between Asian and African elephants, but that does tell us that these two animals are related. They are from the same created kind. So, if they are related, and we can tell that with breeding, can we use that same technique to figure out if the mastodons are related to modern elephants? No, they're dead. So we're not going to be able to breed them and get any hybrids. So we're going to have to try a different technique. Is there anything else we can do to figure out if they are related? Well, we have their bones, right? And we have the bones of modern elephants. So let's look at traits in animals and see if we can use that to figure out how fossil animals might be related. We already know all the cats are connected. They're all related, and they have certain similarities. They have the same basic body plan. So if we look at a fossil and it looks pretty similar to a cat, can we use those evidences? Well, does anyone know of any extinct cats, maybe from the Ice Age period? Saber-tooths, yeah, smilodons, there we go. So it's an animal about the size of a tiger today, though it certainly had some odd features. It had saber teeth, right? These huge canines here that are definitely much larger than the canines in any cat today. They were surprisingly fragile, too. We don't actually know what smilodons use these for. And we think they had to open their mouths over 100 degrees just to be able to fit food inside. So that's not something we see in cats today. But let's consider their toes. All right, here is the toe bone from a smilodon. Here's the part where the claw grows from, and that is basically identical to the same bone in a cat today, the phalanx, the end of one finger. Why is that important? Because this joint right here that connects to the rest of the foot, in tigers and in all other cats, that is used for retracting the claws. It has a very specific hinge shape that allows it to hinge backwards, whereas you can't quite do that with your toes, right? So the effect is, the fact that we see that that same shape is in the joint of the smilodon's toe is a strong evidence that it is also a member of the cat kind, an animal who had retractable claws like cats today do. Let's take a look at our camels again. If we look at their skulls, for example, here is the skull of a llama. And if we look at their teeth, they have certain characteristics. They've got flat, grinding molar teeth, and they have no top teeth in the front. If you look real carefully at llamas, you might be able to see that. But that's the same thing you would see in a goat or a deer or a cow, but we don't think they're related to those animals. So what tells them apart is these fighting teeth, those huge canines there, which is what llamas will use to fight with each other. I'm much more worried about being bitten by our llamas than being spit on by them. So, if we find a fossil of an animal, that has those fighting teeth, that's a strong indication that we are also looking at a member of the camel kind, one who's related to our llamas and camels. So if we go back to our elephants, our mammoths, our mastodons, sure, the mastodons have weird teeth, and the mammoths are covered with dense brown fur, but otherwise, all their bones are basically identical to each other. So do we know for sure that they are related? Well, not without being able to breed them, but their bones are a strong indicator that they are probably members of the same created kind, from the same original ancestors that God made. And if they are, now we can place them in history. When did these animals live? So, to help us out with that, we're going to talk about another group of animals. Let's talk about horses. Anyone here like horses? Yeah. All right. So, there's a beautiful horse there. And there's another animal who looks a bit like a horse. That would be a donkey. Yes. So, that is Josephine, who lives here at the Creation Museum. Are these animals related? Yes, they are. You can breed horses and donkeys, and depending on who the father is, you get a mule or a hinny. All right? How about this animal? This is Zacchaeus, the zebra, who lives at the Ark Encounter. Is he related to horses? Well, he definitely is. If you don't believe me, go down to the Ark and you will meet Zoe and Cletus. Zoe's on the left, Cletus is on the right. They are zebroids. Their father was the same zebra, but Zoe's mother was a quarter horse, and Cletus's mother was a mammoth donkey. So they are a zorse and a zonkey, respectively. What does that tell us? Zebras, horses, and donkeys are all related. They are from the same created kind, the horse kind. So, if we consider the account of the flood, we run into something interesting. Noah was given directions to bring animals onto the ark to preserve life from the flood. And we're told that he was told to bring the birds according to their kinds, animals according to their kinds, creeping things according to their kinds. The same word that God used when he made the animals. So did Noah bring 2 horses, 2 donkeys, 2 zebras? He did not. He would have brought male and female of the equid kind, the group that those animals belong to. So when we were building the Ark Encounter and we needed to represent the equid kind, we did it like this. There we go. That is an animal that doesn't quite look like what you'd expect because it's based on a fossil, this fossil. It's called Mesohippus. It's a fossil horse that's found in the middle of a bunch of other horse fossils, hence why it's called the middle horse in Greek, Mesohippus. You might notice something about this horse immediately. It is very small. Yeah, this animal is about 2 feet tall, 3 feet long, roughly the size of a greyhound, which is odd because all of its descendants today, horses, zebras, and donkeys, are a lot bigger than that, right? So what are we saying? Are we saying a tiny animal evolved up into much larger animals? No, actually. We're saying that whatever those ancestors were, they had the genetics to produce a lot of variety. So, Mesohippus may not have definitely been the ancestor horse, but whatever those 2 animals were, they had the genetics to produce the stripes and zebras and the spots and Appaloosas, and every size from little Falabellas all the way up to giant Clydesdales, right? Even among the wild horses, we see some much larger fossils, like Equus giganteus. Here's a tooth from one of those giant horses. That was a horse that lived here in North America during the Ice Age and got to about 3,000 pounds. And all that variation in size came from just 2 animals on the ark. So those 2 animals didn't necessarily have to look like any of their descendants. They just had the genetics to produce a lot of variety. So, how quickly did they do that? How quickly did they go from 2 animals to many different species? Well, later on in Genesis, after the flood, we have the account of Joseph. Everyone remember Joseph? Yep. He got sold into slavery in Egypt. He became the ruler of Egypt, second only to Pharaoh, and there was a famine, and the Egyptians needed food. So we're told in Genesis 47 that Joseph gave the Egyptians food in exchange for the horses, the flocks, the herds, and the donkeys. Both the horses and the donkeys are here, and there are separate words for them, which means, if we put them on a timeline of Noah and his descendants, there's the flood, there's Joseph, and from 2 animals on the ark, within a span of 600 years, we have gone to species that are so distinct from each other, there are separate words for them. That's our time span in which we can expand from just 2 animals to these many descendants. And likewise, going back to our elephants, we can go from just 2 elephant-like ancestors on the ark to mammoths, mastodons, modern elephants in that same time span. But there is an interesting question built in there. Why did they break apart? Why didn't they just stay one type of animal coming off the ark? Why would they break into species? Well, let's consider another animal group. Let's talk about bears, right? There are the two bears you can see up on the first deck of the Ark Encounter. So we believe there are two bear ancestors to all bears today. But bears are quite different from each other because they live in very different places, right? Bears spread out across the earth from the Ark. Some of them ended up in the tropical rainforests of Southeast Asia. And those who live there have short fur to deal with the heat. They have small bodies that don't build up as much heat. And they have long tongues that help them get sweet things and insects out of trees. They are the sun bears. In the bamboo forests of China, we have a bear who uniquely eats bamboo, the giant panda. And way up north, there's basically no plant material at all. So we have a much larger bear that can deal with the cold, has fur for blending in, and is adapted to swim and eat marine life, the polar bear. And all of that variation comes from just two bears, but their descendants spread into different parts of the world, where some did a little better than others, and we get different species from one created kind, as those genetics break out. So why would we see woolly mammoths, for example, from the elephant kind? Well, there was something big that happened after the flood that would have possibly allowed these woolly animals to do a little better. There was an ice age, a period where there was a lot of ice covering a big chunk of the earth. Not everywhere, but let's talk about how we even know that there was an ice age. First off, the Bible doesn't actually say anything directly about an ice age, right? We are drawing this evidence from the geology, from the rocks, but we have some pretty clear evidences. For one thing, there is still a lot of ice at the North Pole and the South Pole, and that ice did not exist during the flood. It had to have formed afterwards, these huge sheets of ice. We can also tell that those ice sheets used to be a lot bigger. Now, how do we know that? Well, for one thing, we can actually watch glaciers receding backwards. It happens in different places at different rates, but when that happens, they leave behind clear evidence of where the ice has been. For one thing, glaciers move, and they grind up the rocks underneath them, and they leave glacial till, this kind of gravel that's very characteristic of where a glacier has been sitting. They also pick up huge rocks and they deposit them in other places. So we get erratics, these huge rocks that are from one part of a continent and laid down in a different place. And wherever the glacier got to at its furthest point, it leaves a moraine, this big mound of dirt that the ice pushes up with the weight of it, and then it recedes back, leaving that mound behind. And so those show us where the furthest extents of the glaciers were. And there were glaciers right here in Kentucky. In fact, we are standing on land that used to be covered by hundreds of feet of ice. This is actually about the southernmost extent of the glaciers. The Ark Encounter sits on land that was never covered by ice, but yes, huge chunks of North America used to be covered by sheets of ice, along with Asia and Europe, and of course, Antarctica. So why was there so much ice? Well, the biggest cause behind this is going to be the global flood. It was a big event, right? We see in Genesis that in the 600th year of Noah's life, all the fountains of the great deep burst forth, and rain fell on the earth for 40 days and 40 nights. Notice, the rain didn't happen first. Something happened in the ocean first, something down in the deeps. We think from geology that there was a lot of tectonic movement, the plates holding the continents shifting around, and that would have caused a lot of volcanic activity down in the ocean basins. So you got heat coming up from below, warming up, boiling the ocean water. And boiling water is going to release a lot of water vapor into the atmosphere. The flood was a really wet period, not just because the land was covered with water, but because the air was full of water as well. So lots of rain and lots of snow falling onto the continents as they become exposed towards the end of the flood. Now, as that snow is falling, it should just melt every summer, right? Just like it does now. Except there's something else volcanoes do. They release aerosols, little particles in the atmosphere that block sunlight and keep it from reaching the Earth. Pretty much every time there's been a major volcanic eruption, the following year is kind of a bad crop year. A lot of sunlight gets blocked, and plants can't produce as much material. So the same thing would have allowed the snow to build up and build up and build up, and you get huge continental glaciers covering a lot of the far north and the far south. Now, the equator was pretty nice at the time, but a lot of the continents were covered with ice. And evolutionists noticed this too, right? In fact, they believe that this happens cyclically. It happens over long periods of time, so there have actually been many ice ages, but they don't attribute it to a global flood. They attribute it to the tilt of the Earth. So the Earth tilts 23.4-ish degrees off from its center point relative to the sun. But the secular model is that the Earth sometimes tilts more towards the sun, and sometimes it tilts less towards the sun. And when it's tilting more towards the sun, that is a warm period or an interglacial. And when it's tilted away, that would be a cold period or an ice age. Now, there's one big problem with this. If the entire Earth is cooling down because it's all tilting away, everything is cold, including the oceans. And the problem with cold water is it doesn't release water vapor, not nearly at the rate that warm water does. And the only way you're going to get the huge amount of precipitation, to get huge amounts of snow, and therefore huge sheets of ice, is if you have nice warm oceans at the same time that you have really cold continents. You can't have the entire system warming up and cooling down together. But there's another reason we think that the oceans were warm besides just the basic model. We can actually see pretty clear evidence that there were grasslands, warm areas, in places that can't be grassy today, like way up in Siberia, way up north. Bear in mind, all the oceans were warm, including the Arctic Ocean. So any area that's close to the ocean would have been kept warm and green for much of the year. It still would have snowed there, but the snow wouldn't have stuck because those warm oceans would be constantly cool, or keeping those areas grassy and green. And that's exactly where we find huge grazing animals like mammoths living in an area where no elephant-like animal could possibly survive today. It was actually warmer during that period than it is now. So the effect is, the global flood is the only way we can explain why there were grasslands in the middle of an ice age in an area that far north. And those grasslands also play into how those animals got here. One of the effects of having so much ice on the continents is that the water has been pulled out of the ocean. It's sitting up on top of the continents, and that is going to drop the ocean level. And the effect is that the shallow parts of the ocean then become land bridges. And since they were also kept warm by those warm oceans, you have these corridors of green grassland that allowed huge animals to walk from the Middle East, across Asia, over from Russia to Alaska, and down into North America, where we find these fossils of these huge animals. So this seems to be how we got our Ice Age giants. Not trudging across huge layers of snow, but actually coming across on lovely grasslands during that Ice Age period. And that's where we get our Ice Age giants. So who exactly were they? Let's talk about who the giants were. Because during this time period, we see some of the largest fossils from some of these animal kinds that we have ever seen. And some of the largest lived here in North America. So we're going to focus on a few of these animal kinds we talked about and who their largest members were. Let's start with the bears. All right, we got bears of all kinds today, but they're all roughly the same size. Right? The polar bear is the largest, and of a similar size is the cave bear that we see from that Ice Age period. Here's its skull. So this is a species of bear found in caves in Europe. No surprises there. Many thousands of these have been found in caves, and they're pretty good-sized animals. But they're not much bigger than a polar bear. What was a whole lot bigger was the short-faced bear. That's one that lived over here in the Americas. It was about 6 feet tall at the shoulder, may have stood up to 10 feet tall on its hind legs. Thankfully, we think from its teeth that it mostly ate plants, but I still would not want to face off with one. Now, another animal that's much smaller today is the armadillos. Here's a couple of the armadillos that live down at the Ark. We have Esau on the left. He is a large, hairy armadillo. And we have Pebbles, the southern three-banded armadillo. Now, has anyone ever met an armadillo here in the US? We have them down south in Texas, Florida, parts of the south. We have the 9-banded armadillo, which is a little bit larger than these guys, but most armadillos today are only about so big. The largest species, the Brazilian giant armadillo, gets maybe 4 feet long, but they're all relatively small, but still well protected because they have armor, right? So they're in their name. They're covered with little plates of bone called scutes that protect them from the predators that want to eat them. And we find those same bony scutes on much larger fossil animals. Here's a couple of those scutes from Florida. These belong to a group of armored mammals called the glyptodonts. So they were pretty good size, though it's a little bit hard to get a sense of scale here. The largest glyptodont was called Doedicarus. It was about the size of a Volkswagen Beetle, roughly 4 feet at the top of the shell, may have weighed up to 1.5 tons, and it had a clubbed tail that may have had spikes on the end of it. So I really don't want to meet one of those either, but that was around here during that time. One of my favorites is to go talk about the camels. So we've seen how there are camels over in Africa and Asia today, and llamas and alpacas down in South America. But how did they get there? So starting from the Ark, they could have crossed over the land bridges to get to South America, but that means they would have had to cross through North America, right? And yet we don't have any wild camels here now. But we do find plenty of evidence. We have this footprint, which is from a fossil camel that was in Arizona, where we certainly don't find any camels now. And we find lots and lots of camel fossils. So here, for example, are the teeth from the llama compared to the molar tooth of one of those fossil camels. They come in all sizes, some of them smaller than llamas today, but the largest was called Titanotilopus. It was about 11 feet tall at the shoulder. It may have weighed up to 2.5 tons. And that was running around in Nebraska during the Ice Age. Now, probably my favorite to talk about is sloths. They're amazing animals. Here are the two sloth ancestors we have at the Ark encounter on the first deck. They're pretty small animals, but their descendants today are pretty small too, right? There's Felix, the Hoffman's two-toed sloth, down at the Ark. He's a cute guy. There's also 3 toed sloths, 5 species total, all found in South America, and all living in trees, because sloths are very, very slow. It's because they don't have very much muscle mass. They don't move well on the ground, so instead they use their long claws to grip onto trees, and they have sharp peg-like teeth for chewing through all kinds of greens and fruits. So how did tiny tree-dwelling animals get so far away from where the Ark landed? Well, the ones we see as fossils are not small, slow, or tree-dwelling. They're giant ground sloths. So these animals were much bigger. Here is the peg-like tooth from one of those animals compared to the teeth of the modern sloth. The largest of them here in the US was called Eremitherium. This guy was at least 13 feet tall. There is the claw from the tip of one finger. This animal may have weighed up to 6.5 tons, which means it's comparable to a modern elephant. And we still think it's from the same pretty kind as the cute little sloths we see today. They were majestic animals, but not the largest. The largest mammals in North America were the mammoths and mastodons. They were members of the elephant kind, and some of them, like the Columbian mammoths, may have reached as much as 10 tons, which is larger than African elephants today. And they still weren't even the largest mammals. They were just the largest ones on this continent. We actually find even larger mammals over in Asia. The largest elephant was called Paleoloxodon. We found its leg bones in China. It may have weighed 22 tons, and it still wasn't the largest. So there's one specimen that we think might be larger than Paleoloxodon. It's called Paraceratherium. Its ancestry is a little hard to trace. It looks an awful lot like a rhino, so it might actually be a member of the rhino kind, but it is taller than a giraffe. And it may have weighed as much as 24 tons. By far the largest mammal that we've ever seen. You could have walked straight under it without brushing your head. So, these huge animals got here because there was a flood. Following that flood was an ice age that allowed these animals to reach North America. And yet we don't see any of them today, right? So what happened? Well, the main thing is, are we still living in an ice age? Nope. Thank God this museum is not under hundreds of feet of ice, right? So the conditions produced by the flood eventually ended. Mainly, the oceans just cooled off. There was no longer that heat being added from below, and so without all that heat, there was less water vapor being added to the atmosphere, and less snow being added to the glaciers. Also, with less water, the temperatures started to vary a lot more. The winters got colder, and the summers got hotter. And in both cases, everything got drier, so that started the glaciers melting back, and a lot of those beautiful green grasslands that were supporting huge grazing animals, they started to turn into desert, and in the north they started to become tundra. So on the left is Arizona and New Mexico during the Ice Age, covered with plenty of woodland, and on the right is what it looks like now. That mural we've been seeing this whole time, that is from White Sands National Park. It's a mural based on the animals you can find buried in that area. And this is what White Sands looks like now. I don't think mammoths or mastodons would be capable of grazing on that. In fact, even more famous deserts formed towards the end of the Ice Age. like the Sahara Desert. So during the Ice Age, most of Africa was either rainforest or way up in the north, huge grasslands. You could see Lake Chad, the largest lake that ever existed on Africa, there. And now it is completely gone, all turned into the largest hot desert in the world. And yet, out there in the middle of the Sahara, we find rocks with art left by people who saw the animals around them, and there were the elephants living in the middle of what is now that vast desert. And that plays into probably another factor into why we don't see these huge animals anymore: people. Now, Noah's descendants didn't initially do what God told them. He didn't fill the earth. They tried to stay together, reunite their society by building a tower at Babel. It didn't really work out for them, did it? No. God confused their language, and we see that he dispersed them over the face of all the earth. So tribes started spreading out from Babel, and we see some of them going over the land bridges into North America. How do we know? Well, there's art. Now, this is a depiction from France of some of the art left by those post-Babel people of the animals they saw, things like ibex and deer and mammoth. But over here in the US, one of the oldest pieces of art that we know of is in a private collection. It's a little piece of mammoth bone with another mammoth drawn on it. So there were definitely people over here interacting with the mammoths, and we're pretty sure we knew what they were doing with them too. These are Clovis points, one of the earliest forms of projectile point found in the US. Some of them are made out of mammoth and mastodon bone. Particularly, if you go up to the lobby of this museum, you'll see the burning tree mastodon. It is one of the most intact mastodons ever discovered on a golf course in Ohio. If you look real close at its ribs, here's one of the examples. There are little cut marks. We think this animal was probably butchered. People were hunting and eating these animals. And bigger animals make for better hunting, so that may have spelled the end for the largest of these Ice Age animals. So they're all dead, except that they aren't. There are some of them still around. Here is one of the skulls you could find at Big Bone Lick. Here's a tooth from that animal. And it's basically identical to the skull of a living animal because it is that animal. It's the American bison. They have a small herd of them at Big Bone Lick to give you a sense of what some of these Ice Age giants were like. Bison arrived at the same time as these mammoth and mastodons. They lived in the same areas. They were buried in the same fossil pits, right? They are Ice Age giants, along with everything else I talked at the beginning. The bears, the moose, the elk, those are all also technically Ice Age giants. So, those huge animals that we see only as fossils, they're extinct because the conditions continued to change at the end of the Ice Age. And yet, now when we look at these bones, how they're distributed around the world, and how the animals related to them are found in the areas they are today, how we get llamas and alpacas all the way down in South America, the best way we can explain this is through Scripture, that the flood caused an Ice Age that allowed these animals to disperse over the world. And if we can trust Scripture about our history, what it tells us about how God made the animals, how he saved them through the flood, then we can also trust him about how he has sent salvation for us as well, right? He sent his only son, Jesus, who became a man, lived a sinless life, and through his death and resurrection, he opened the way that if we put our trust in him, we can join him eternally in a new heavens and a new earth where all of creation is going to be restored. So I hope you're heading there as well. If you like learning about this and you want to know more about the Ice Age, I didn't cover a lot of the details, but there's a lot more you can learn from Flood Geology. It's a DVD that covers more of how the flood actually worked and what mechanisms then caused the Ice Age. We have a DVD on that as well by Michael Ord. He is kind of the leading creation scientist in Ice Age research, so he's also written some wonderful materials, particularly Frozen in Time is an exploration of those frozen mummified mammoths and how they ended up exactly where they were. There's also a version for families, and he's got a great version called Life in the Great Ice Age that explores the life of a child living post-Babel alongside many of these animals. Plus, Buddy Davis has produced a wonderful DVD called Buddy Davis's Amazing Adventures Ice Age. He goes up to Alaska, explores the glaciers, and many of the animals that lived during this time period. We also got a special deal called You Choose. Green stickers on any of the items in the gift shop or out here. If you see these items with these stickers, you can bundle them together and save yourself some money. So I hope you enjoyed learning about some Ice Age giants. I'll be glad to answer any questions you have here at the end, and thank you for joining us here at the Creation Museum.